Okay, this video tutorial looks at the mathematical strand of measurement and geometry, and more specifically, we're going to focus our understanding on angle pairs and angles within parallel lines. Okay, the first thing we need to understand is that when you draw lines on a flat surface, they are one of two things. They are either parallel, all right, meaning they will never meet, and they are always the same distance apart, no matter how far you travel along them, or they are going to be intersecting, where they create a bit of a cross at a place that we call the point of intersection. And you can see a point of intersection up here where these lines are intersecting. So the point of intersection is where the two lines cross. When we're looking at two lines that intersect, all right, or create a cross, like we've just talked about, they actually create two sets of angle pairs. And these angle pairs are called vertically opposite, and they are equal in size. Okay, so you can see with our diagram here that we have an angle with x and an angle with x. They are the same size and they are opposite each other across the point of intersection. That's why they are called vertically opposite. And we also have another couple of pairs here where we've got a little dot and a dot, all right, and they are going to be equal in size because they are directly opposite each other. All right, so the opposite angles at a point of intersection are always equal, and they are called vertically opposite angles. Now, when we're talking about parallel lines, okay, sometimes parallel lines are crossed by a third line, and this third line is called a transversal, okay, because it crosses both parallel lines. And when it does that, there are three different types of angle pairs that are formed. These are corresponding, alternate, and co-interior. And we're going to go into a bit more detail for those three types of angle pairs on the next few slides. Okay, so the first angle pair that we're going to talk about involving parallel lines is called corresponding angles. Okay, so corresponding angles are equal in size, all right, and are in the same relative position of an intersection between a parallel line and a transversal. So what that essentially means is, let's use a different color. Here is an intersection, okay, between a transversal and a parallel line. And here is another intersection between the transversal and the opposite parallel line. But what you will notice is the angle that's been highlighted is in the same relative position. So in this particular case, they're all in the top right-hand corner. Okay, so both of these angles are corresponding because they are in the same relative position on where the transversal meets the parallel lines. Okay, so if these angles are in the same position or relative position where the transversal meets the parallel lines, then they are corresponding and they are considered equal in size. In this particular example, we're looking at alternate angles. Now, alternate angles are also equal in size, all right, but they are not located in the relatively same position. Okay, they're actually located on opposite sides of the transversal. So we've got our transversal in green now coming through. You can see that our angles are actually on opposite sides of the transversal, but they're actually inside the parallel lines. Okay, so the parallel lines are running horizontally in this particular case. And you can see that our both angles that we've marked with a blue dot are on the inside of the parallel lines, but on opposite sides of the transversal. They are alternate and they are equal in size. And the last pair of angles that we're going to talk about are co-interior angles. Now, co-interior angles add up to 180 degrees. So when you add them both, you get 180. And they are on the same side of the transversal. So the transversal, again, is here. Co-interior angles are on the same side and inside the parallel lines. Okay? And they add up to 180 degrees. Sometimes they're also called allied angles. Okay, so let's have a look at a bit of an example or a few example questions involving our understanding of angle pairs. The first one says identify the corresponding alternate, co-interior, and vertically opposite angles to the blue triangle in the following diagram. The first one I'm going to do is corresponding. Now, corresponding means that they're in the same position but on a different point of intersection. Right? So in this particular case, F and the blue triangle are both in the same relative position but at different points of intersection. So F is corresponding. The next one is alternate. Okay, alternate are on opposite sides of the transversal but inside the parallel lines. So B would be alternate. The next one is co-interior. Now co-interior is on the same side as the transversal and inside the parallel lines. So G would be co-interior. And my last one is vertically opposite. Now vertically opposite is the same point of intersection but directly opposite the blue triangle. In this particular case, it is C. So C is vertically opposite. Now the next question down the bottom says calculate the size of the unknown angles below, giving reasons. Now if we look at the S here, okay, and the angle of 121, they're actually corresponding angles because they are in the same relative position, but on different points of intersection. And we know corresponding angles are equal. Therefore, S must equal 121 degrees. In our next example, we've got S and 140 degrees all within or inside the parallel lines and on the same side of the transversal. So that tells me these are co-interior angles. And we know that co-interior angles add up to 180 degrees. So S plus 140 degrees must equal 180 degrees. Therefore, my S must be 40 degrees. Okay, here are some practice questions I'd like you to have a go at. Please feel free to pause the video and have a go at them. When you think you've got the right answers, continue the video and we'll see how you went. Just in the first part, it says describe the following angle pairs. Please describe them as either vertically opposite, alternate, co-interior, or corresponding. Okay, so let's see how you went. Now A and D would be co-interior. A and B would be alternate. D and E are vertically opposite. And A and C are corresponding. Now my second few questions here, it says decide if the figure contains parallel lines. Well, in our first example, we've got alternate angles and it says they're both 50 degrees. We know that in parallel lines, alternate angles are the same or are equal. Therefore, yes, the lines must be parallel. Okay, because those alternate angles are equal. If those alternate angles were not equal, then the two lines that they've given us would not be parallel. But in this particular case, they are. In our second example, we've got, looks like co-interior angles. We know in parallel lines, co-interior angles need to add up to 180. In this particular case, it adds up to 160. So therefore, we can say that no, these lines are not parallel. Okay, if it was parallel, we would have to have co-interior angles that added up to 180. So I'm going to draw these lines on here, but I'm not going to put my arrows because they are not parallel.